Now we've come to the point of why the packaging was designed in the first place. To maintain the quality of your product to its destination, the packaging has to have performed properly. In most cases, products ship everywhere, every day, with no issues of damage from rough handling, punctures, vibration damage, or dropping. When, however, these events do occur, new issues come to light concerning damage and returns. This section will help you to recognize and prevent damage. There are many ways a product can be damaged during transport. Some common causes are severe impact, package design flaws or failures, improper stacking resulting in crushing, the end user improperly handling or unpacking, hidden damage from internal cushioning or bracing failure. Occasionally, when products are damaged or destroyed, the blame game can come into play. We all use freight companies and hire carriers at some time. To make sure that the cause of the damage and the parties involved are identified for insurance purposes, ValleyBox recommends some basic steps be implemented to protect your company. First, you need to identify what the cause of the damage may be. If you've identified your company as a Type 1 manufacturer, your packaging could be very repetitive and standardized, with a production line that is packaging larger amounts of product every day. A consideration to lab test the packaging may reveal the cause of damage. For all types of manufacturers, other steps should include taking a photo of the packaged product prior to shipment. Ask the same of your client if it has received damage. If you suspect the carrier is mishandling your shipment, include damage indicators like a tip and tell or shock watch. If there are handling, transport, and unpacking procedures, make sure to include visual instructions on the outside of the package. After you've identified the cause of damage, some solutions might be changing your packaging procedures, choosing an alternative solution to improve the packaging performance. Know your distribution environment and possible variables associated with land, sea, air, or rail transport, and safeguarding against fraudulent damage claims with damage indicators. Here's a case where hidden damage occurred and was not detected until the part was installed and failed to perform. A process of elimination was used to target the exact cause of the packaging failure on the returned parts for this rod manufacturer. The first step was to include a tip and tell and shock watch in the packaging to determine if mishandling was occurring by the contracted carrier. The second step was to perform an ISTA vibration test, which revealed that the packaging was failing to keep the rod secure. From this information, ValleyBox created a custom guillotine-style foam insert to eliminate the vibration and save the fragile rods from any damage during transport. When the new package design was implemented, the rate of damage returns went from 36% annually to 0. In turn, this increased overall customer satisfaction, as you can imagine. The International Safe Transit Association, or the ISTA, has 4 basic categories of hazards that may occur during distribution: shock, vibration, compression, and atmospheric. Each hazard category has a major test category associated with it, and there are 13 associated test types. Contact the ISTA for further information on package testing at ista.org. Heat-treated wood is mandatory for overseas shipments with wood outer packaging. The heat treatment program was developed in order for the American Lumber Standard Committee to implement a quality control program for official labeling of heat-treated wood packaging material with the ISPM 15 official mark. Of course, this came from the need to control plant diseases worldwide and compliance with the U.S. Department of Agriculture. If the lumber used on an overseas shipment does not bear the official mark, there could be a holdup in customs and potential liability. For those of you familiar with customs inspections, the last thing you want is for your product to be waiting in port. For example, this import-export company was experiencing long wait times during custom inspections. The container was not easily opened for verification, and the vapor barrier bag was left open, exposing the sensitive machinery to atmospheric moisture, resulting in corrosion damage. By installing an observation port on the exterior wood container and a viewing port in the barrier bag, this allowed customs to perform their tasks without breaching the seal or the container. A humidity indicator was visible through the observation port. This provided a method to confirm the integrity of the vapor barrier bag without opening the box. This observation port design successfully reduced damage claims to zero and expedited all future customs inspections.